Okay, starting the movie again because somebody decided to show up into my class. Hooray, yay. I love students so much. Just kidding, just kidding. Welcome. New beginning. So, last video we were talking about multiplication of radicals. And now we are moving into the division and rationalization of radicals. I'm not going to let you get to me. You're not going to get in my head. I don't care. So, the rule that we use for the division of radicals is very similar to multiplication. So for division, it looks like this. So when I get a situation like this where I have two mixed radicals, they have to have the same power. But when I get that, I can rewrite that as m divided by n. Gee whiz! See what I am doing here? Oh my goodness! Over a over b. I'm in a really bad school. Real mean kids here. This is like my dangerous minds job here. You won't get that, you're too young. Okay, so what happens is we basically can divide. We can put a and b under the same radical root, and we can do the division like that. So what does that look like? Well, if I have something like 4 divided by 3, 4 cubed root of 6 divided by 3 cubed root of 2, well, I can rewrite this as 4 over 3 times the cubed root of 6 over 2, which is 6 divided by 2 is 3, so I can get 4 cubed root 3 over 3. Okay, and this is what I can do with division. So let's do another example. So let's say I had 3 root 22 over root 11. Well, in this case, this can be rewritten as 3 square root of 22 divided by 11, which is 22 divided by 11 is 2. So it's 3 root 2. That is division. You're super impressed, I know. So what happens in the situation where this doesn't work out to be a very easy division? It doesn't divide into a nice whole number like we got in these examples. Well, that's where we get into having to use a process called rationalization. And basically rationalization just means that we are getting rid of the root in the basement or in the denominator. So if I was given a problem like 20 over root 10, here I don't have any root on the top that could work with this root to do a division like here. So I'm going to have to do a process called rationalization where I know that the square root of 10 multiplied by the square root of 10 is the square root of 10 times 10, which is 100, which is the square root of 100, which is 10. So I know that root 10 times root 10 is 10. So if I multiply the bottom and the top by 1, which means I'm not doing anything, I'll get this. So now, I get 20 times root 10 on the top, and then I get 10 times 10 on the bottom, which is 10. Now, I don't have a radical in my denominator, so this is good. And then if I were to simplify this, it would be 2 root 10. 20 divided by 10 is 2 root 10. So let's say I had, let's say I have 7 root 2 divided by root 11. Okay? Again, this is a case where I'm not going to get a very clean division. 2 divided by 11 doesn't work. So I'm going to rationalize it because I have a radical on the bottom. So I'm going to multiply it by root 11 over root 11. Stop clicking your pen in my video. Stop it. It's not even funny. Okay. And I get 7, and then 2 times 11 is 22. And then in the bottom, I get over 11. And I'm done. 7 over 11 I can't really simplify. Root 11 times root 11 is 11 times 11, which is a perfect square. It just becomes 11. Okay? So that is that. And then what happens in the situation where I have something like this, 5 over 2 minus root 3? Okay? How do I rationalize something like this? How do I get rid of the roots? Well, we use a little law, a little difference of squares. We use a difference of squares law, which tells us that if I have the square root of u plus the square root of v, to get rid of all the roots here, I could multiply it by the square root of u minus the square root of v. And this minus is going to give us a difference of squares. U times u, root u, that's u. And then I get minus root uv plus root u times v here, and then minus v, because v times v, root v times root v is v. These cancel out, and I'm just left with u minus v at the bottom. That's called the difference of squares, and that's how we get rid of this. So what do we do in this case? Well, we multiply it by 1, but we put the 1 in a difference of square form. So 2, all I do is I change the sign here. And 2 plus root 3, so this is 1. This is 1. But it's going to create the difference of square down here that's going to allow me to get rid of my root 3. So the top will be 10, and then 5 times root 3 plus 5 root 3, because this is a binomial. And then it will be divided by, I'm going to get 2 times 2 is 4. And then I'm going to get 2 times root 3 is plus 2 root 3. And then I'm going to get minus root 3 times 2 is negative 2 root 3. And then I'm going to get negative root 3 times root 3 is minus 3. Then this is going to cancel out. So now I have no more radicals in my denominator. And this will finish off as 10 plus 5 root 3 over 4 minus 3 is 1. Over 1, which is just 10 plus 5 root 3. Okay. So one more to make it interesting. So what if I had 7 root 2 over root 6 plus 8. I'm going to multiply this by root 6. The difference of squares is going to make this negative, minus 8 over root 6 minus 8. And then if I do this multiplication on the top, I'm going to get 7 root 12, and then minus 56 root 2, 7 times 8, all divided by, now I know that the difference of squares is going to get rid of my middle term, so I'll get 6 minus 64 on the bottom. And if I go through this, I'm going to get 7 root 12 minus 56 root 2 minus over negative 58. I feel like I made a mistake here, but probably not. Okay. 6 times 2 is 7 root 12. Ah, yeah, so this 12 can break down. So I can break this 12 down because it's not in its simplest form as a radical. So that can become, that's 2 root 3. So I'll pull out a 2, this will be 14 root 3. And then if I divide everything by 2, I get, and divide out that negative, I get negative 7 root 3 plus, because that and that work together, plus 28 root 2, all divided by 29. Okay, so that's how we rationalize our radicals. Great. Awesome. Perfect. Thanks.